Hello viewers, welcome back to class. I'm super excited to have you guys back to class again. Don't forget, this is Master Builders Online Academy. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos. Like our videos, share our videos, and ensure that you obey some of our rules and regulations. One of the policies that we strictly follow here is that as you watch this video, you should not skip any part of this video for your own advantage. Are you there? Then also avoid every unnecessary distractions anytime you are set to watch and to learn from this platform. Then finally, if there is any part in this video you do not understand, you stand the chance to replay the video over and over again until you understand that particular aspect of the problem that is giving you challenge. And I bet you understand it. But if at the end of replaying the video over and over again, then you still do not understand some basic aspect of it, or you still have questions to ask, guys, just go down to the comment section and make your necessary comment. We will attend to your comments. Now, let's get to work. On the board, we have solutions to first order differential equations. And for those that have been following us, we have been looking at first order differential equation for quite a number of time now. We have looked at formation of the first order differential equation, second order differential equation, and other orders of differential equation. We have looked at solution to first order differential equation by direct integration. We have also equally looked at solution to first order differential equation by separation of variables. Now, in this class, we are going to be looking at solution to first order differential equation using the homogeneous equation, which is by substitution method. Alright, so in this case, we substitute y is equal to vx. But like I explained in our previous lesson, please guys, if you are visiting this page for the very first time, or you get to access our lessons on differential equation for the very first time, please you can go to the playlist section of our channel and look out for differential equation, where we see the previous lessons we have looked at before this current video for better and proper understanding. Alright, so some of the things that we have discussed in our previous lessons, we are going to be applying them here now. So we may not go in details. So for you to understand the basic concepts of this course, of this particular topic, guys, all you need to do is to go to our playlist and watch other related videos on differential equation. Because like I said earlier, this is a continuation class. Now let's get to work again. Now, so I explained that we have 5 methods of solving first order differential equation. And how do we know first order differential equation? We say when we have the y over the x, this is first order. When I have this square y over the x square, this is second order. Alright, so we do not have the time to start looking at all of this in essence. Okay, now, if this is understood, I explained that these 5 methods of solving first order differential equation or providing solutions to first order differential equations, they practically obey the condition of the question that you are given. So first order differential equation comes in 5 different ways. And that is why 5 methods are required. Alright? So not every problem that you are given under first order differential equation can be solved with the first method. So different methods solve different category of every first order differential equation. Are you there? Now guys, if that is understood, I remember I explained how to know problems that are being solved with direct integration when dealing with first order differential equation. I equally explained how first order differential equation comes for you to make use of the separating the variable method. Now I want to quickly also explain how question in first order differential equation comes for you to apply the homogeneous equation. Because the problems that separating the variable can solve, there is no need using homogeneous. In fact, the homogeneous equation cannot solve it. So homogeneous equation solves problems that separating the variables cannot solve. So how does questions, first order question comes that we now make use of homogeneous equation. Now listen carefully. First order differential equation comes in such a way. First order differential equation comes in this way. F as a function of x and function of y. Now listen guys. For you to be able to solve problems with homogeneous equation, you must ensure that that first order differential equation you are given is a function of x and y at the right hand side. Of course, the left hand side is always dy over ds, and if peradventure you have a coefficient attached to dy over ds, you must ensure that you divide both sides by that coefficient of dy over ds, so that the coefficient of dy over ds is 1. Are you there? So if this is understood, you must ensure that at the right hand side, the equation you are given is a function of x and y. But now the question is, how will x relate to y? What will be the relationship between x and y? You know, when we were dealing with separating the variable, which is also a function of x and y, we said that x and y are related either with multiplication or division. But in this case now, x and y are related with what? Either subtraction or addition. Get this clear? In other words, there is no way you can separate x from y in such a way that the relationship between x and y will be a product or division. Are you there? So in this case, you will not be able to factorize x out of the function or y out of the function. So now, if this is understood, so understand that for you to use homogeneous equation, you must ensure that you cannot factorize the expression in such a way that you will deduce the relationship between x and y to be either a multiplication or division. So if you try your possible best and you find out there is no way you can do that, then guys, that is where you now come in using homogeneous equation. So what does homogeneous equation do? Homogeneous equation helps you to take a step further that will take you to a level where you can now separate the variable. Since this equation cannot be separated, since x cannot be separated from y or y cannot be separated from x, all I need to do is to substitute in something so that if I take one or two steps, I will be able to separate the variable. Why do we really need to separate the variable, guys? You understand that to be able to provide solutions to first order differential equation very well, you must be able to what? You must integrate the function to be able to get the general equation. And for you to integrate, you must ensure that you have one function to the left and one function to the right. So not until you get to this level where you have one function at the left hand side and the other at the right hand side, you cannot integrate. And if you do not integrate, there is no way you can get the answer to the first order differential equation. So if this is understood, guys, therefore, we need to find a way to separate these variables so that one can be at the left and the other can be at the right. That will now prompt us to a point where we will introduce our integral, then integrate to get the final answer. Now, so in this case, what you do is, since I cannot separate y from x or x from y, I will therefore replace y with vs. So this is what we call equation 1. So when you are solving problems on this, you make use of equation 1 and equation 2 at the same time. Once you substitute equation 1 and equation 2, then simplify, what you will get, you will be able to separate the variables, which is v and x. You will be able to separate them. Are you there? So at that point where you have successfully substituted for y and dy over ds, which is equation 1 and 2, you will be able to separate x from v, which happens to be the resulting outcome. Are you there? Now, if this is understood, after you have successfully substituted equation 1 and 2, you will substitute them simultaneously at the same time. Then simplify. Your answer or your outcome will now be in terms of v and x. Once you have been able to relate, once you have been able to simplify to a point whereby the function you now have is a function of v and x, you can now separate. Once you separate that variables, you can integrate. And once you integrate, finally you will now make use of equation 3, because the equation you were given was never in terms of v. So you need to replace v via equation 3. Now guys, let's get to work. On the board, we have the very first question number 1. We are asked to solve the y over the x is equal to x plus 3y all over 2x. And now this is our solution. Okay? Now, when I look at this equation that I have here very critically, you will discover that this right hand side is a function of x and y. At the numerator, I have x plus 3y, and at the denominator, I have x. The denominator is a function of x only, but the numerator is a function of x and y, implicit function. But at this point, there is no way I can factorize x or y out of this function I have at the numerator. Is it possible for me to say, let me factorize? No, because x is here at the first term, but x is not here. And now y is at the last term, but y is not here. That means nothing is common between these two terms. And when nothing is common between two terms, you cannot factorize it. So that means you cannot factorize. Therefore, you see now that the relationship between x and y here is addition. And I explained that anytime the relationship between x and y is either addition or subtraction, you make use of what? The homogeneous equation. And using homogeneous equation, all you just need to do is to say, recall that y is equal to vx and dv dy over dx is equal to v plus x dv over dx. Now that I have identified that this equation that I have here is going to be solved or can be solved only with homogeneous equation, all I need to do is to state my first equation and state the second equation. So this is the first equation, which is equation 1, and equation 2. Like I explained earlier, you make use of the two equations at the same time. So what do I do now, guys? I will come to this given equation. In place of the y over the x at the right hand side, I'm going to replace it with what I have here at the right hand side. Everything I have here for the y over the x, I will replace with this. So I'm going to have this as v plus x dv over dx is equal to, now guys, x plus 3. Now, what is y? Don't forget y is equal to vx multiplied by vx all over 2x. At this point, what next? All I need to do is to what? Take this v. I need this dv over dx to be at the left hand side. But I will take this v to the right hand side. Therefore, I'm going to have x dv over dx is equivalent to x plus. Now, when I multiply 3 by vx, we're going to have v 3vx all over 2x. Now, when I take v from the left hand side to the right hand side, it becomes minus v. It's as simple as this. Then the next thing we are going to quickly do is that at the numerator, we now have s common between the first term and the second term. What do I need to do? I just need to what? Factorize the numerator. And when we factorize, this will have given us x dv over dx is equivalent to x open bracket. Now, since x is common, if I remove x from here and remove x from here, guys, I'm going to have here 1, or divide this by x. I'm going to have 1, divide this also by x. I'm going to have 3v. So this will have given us 1 plus 3v all over 2x minus v. So at this point, this s will take care of this x. You must ensure that as soon as you substitute for y, or you replace y with vx at the right hand side, ensure that when you simplify, x will be totally eliminated. You must ensure that s is totally eliminated at the right hand side. The only place where you are going to have x in this aspect of first order differential equation, most especially when you are using homogeneous equation, is this x that you just have here and the x. That's all. You must not have x here after you have substituted for y. Now, at this point, this would have given us x dv over dx is equal to 1 plus 3v over 2 minus v. Now, this is over 1. All we need to do now is to simplify the right hand side so that we can have only one common denominator. And now, what's the LCM of 2 and 1? The LCM of 2 and 1 is 2. So this would have given us x dv over dx is equal to 2. That's the LCM. So 2 divided by 2 is 1, and 1 times the numerator will still give us 1 plus 3v. Now 2 divided by 1 is 2, and 2 times minus v, we are going to have this as minus 2v. This is it. Then guys, we have x dv over dx is equal to 1 now. 3v minus 2v. We are going to have this as what? Just 1v over 2. Now guys, at this point where we are, you will find out that we now have a function of x and a function of v. Now understand that v is representing y. Therefore, all v functions must occupy the left hand side, while all x functions will occupy the right hand side. So if this is understood, all we need to do now is to separate v from x. So we now need to separate the variables. Alright? Yes, now at this point we need to separate the variables. And now, what must you do to separate the variable is very, very simple. I have taught us this. What you do to separate variables is just to multiply. You can multiply, you can cross multiply. Alright? So assuming we want to cross multiply, we have this multiplied by this and 2 multiplied by this guy. But there is a simple way to separate variables, like I taught when we were dealing with separation of variables, which I'm going to use now. All I need to do is to multiply both sides by, I will create a fraction. Let's formulate a fraction such that when we use that fraction to multiply both the left hand side and the right hand side, we will successfully separate the two variables. Are we there? So now I know that x is expected to be at the right hand side, not the left hand side. So this is wrong. Now this is also wrong. Now understand that this x is at the numerator. This other one now is at the denominator. Are you there? Now this 1 plus v at the numerator here is wrongly positioned because all v functions, we expect them to be at the right hand side. So what do I do? All I need to do is I will identify the terms here or the functions here that are at the numerator. All the functions here that are at the numerator, I will put them at the denominator. While the ones at the denominator here, I will put them at the numerator. All I need to do now is that I'm going to have this as 1 plus v multiplied by x, and the functions that are the numerator, which were wrongly positioned. While the x is at the denominator, that will now occupy the numerator. That's all. So denominator becomes numerator and numerator becomes denominator. All I need to do now is to multiply both the left hand side and the right hand side by this equation or this word expression. Then we have this as x dv. Now we have this as x dv over dx multiplied by dx over 1 plus v x is equal to 1 plus v over 2 multiplied by what? Dx over 1 plus v x. It's as simple as that. Now 1 plus v will take care of 1 plus v. X takes care of x, dx takes care of dx. Hope this is gotten. Now all that we have left here is dv over 1 plus v. While at the right hand side we have dx over 2x, 2 multiplied by x. This is what we have here. Now we have successfully separated the x function from the v function. Now we can introduce our integral, and hence we will integrate. That's all. Once you are able to separate the variables, then you can integrate. Now we will quickly introduce our integral, and this will become 1 over 1 plus v dv is equivalent to integral of what? 1 over 2x. Okay, 1 over 2x dx. It's as simple as this. So guys, when we integrate 1 over 1 plus v, understand that the power of v at the denominator is 1. That is to say, when we integrate 1 over 1 plus v, will we have in the denominator. So anytime you have 1 over a function at the denominator and the power of the variable at the denominator is 1, you just have the ln of the denominator. So therefore, if we integrate this will have given us the ln of 1 plus v, which is equivalent to. Now understand that this is 1 over 2. And when we integrate 1 over x with respect to x, we have this as the x plus k, our constant. It's as simple as that. Don't forget that k is an arbitrary constant or the integration constant. Are we there? Now, all we need to do here is to simplify. Now, if we cross multiply, we can simplify this. Alright? What else do? We don't need to kill ourselves. You don't need to stress yourself that much. All you just need to do here, guys, understand that after integrating, you must come back to equation 3. Because the solution we have here now is now a function of v and x. But understand that the equation came with y and x, not v and x. So we need to replace this v. And now to replace v, we make use of equation 3. Now you simply recall that v is equal to y over x. It's as simple as this. Y over x. Y over x. Now, the next thing we are quickly going to do is to replace v by this value. Then we have ln 1 plus y over x, all equal to what? 1 over 2 ln x plus k. Now, I can decide to simplify this further. You can decide to leave your answer here. Alright? You can decide to leave your answer here. You are done with this. But you can also decide to simplify further. Most especially, maybe you are dealing with objective to get one of the options. But if it is biro and paper, guys, you can stop it. But now let's progress a bit. Now, I can decide to clear up this fraction. Alright? Now, I have denominator here, so I can decide to multiply all through by 2. And if I do that, I'm going to have 2 ln of 1 plus y over x is equal to, when I multiply this by 2, I just have ln x. And when I multiply this, I have 2k. Are you there? Now, the next thing I'm quickly going to do, these 2 that I have here now, I can take it as the power of this. This is long reading, okay? I can take these 2 to become the power of this function. Then I have ln of, now the LCM of x and y is x. So I'm going to have this as x plus y. Alright? Now, all raised to the power of 2 is equal to ln x plus 2k. Now guys, at this point, if I want all these functions to be in terms of ln, I can just take my k, 2k, as what? Ln a. So let's say, let 2k be equal to what? Ln a. This is constant, so you can take it to anything of your choice. 2k is a constant, so you can take it to be what? Anything of your choice. So I want everything here to be in terms of ln, and that's the reason why I'm doing what I'm doing here. So this will have become ln x plus y over x all squared is equal to ln x plus ln a. Now understand that ln x plus ln a is the same thing as ln a times x, or x times a. So therefore, we have that this is ln x plus y over x all squared is equal to ln a multiplied by x. So since you have addition between 2 ln, pick one of the ln, then multiply their functions. That's exactly what we just did now. So that this ln will take care of this guy. And therefore I have x plus y squared all over x squared is equal to ax. And now guys, when I multiply out, I'm going to have this as x plus y all squared is equal to as raised to power 3. Because if I multiply ax by s squared as I just multiply, this would have given us as raised to power 3. This is what we have. You can simplify this further. You can decide to expand this bracket, but let's stop at this point. Don't forget, this aspect of First Order Differential Equation may be very, very lengthy, but it is understandable if you pay attention to the principles. Alright, so now let's look at question number 2. Okay, now very quickly we have question number 2 on the board. Now we are asked to solve the y over the x is equal to x squared plus y squared all over x. So don't forget, the relationship between x and y at the numerator is addition. Now guys, look at this critically. Is it possible to factorize the numerator, separate x from y? It is impossible to do this. There's no way we can factorize the numerator in such a way that we will separate x from y. In as much as that is impossible here, all we need to do is to make use of the homogeneous equation where place y with vx. So all you just need to do, if this is your solution, just say recall that y is equal to vx and dy over dx is equal to v plus x dv over dx. Like I explained before, in any examination, nobody will state that you should solve the following equation using homogeneous equation. No, you are the one to identify the method that is suitable for any given question. And that's the reason why you need to pay attention to identify when to use separating the variable, when to use homogeneous, when to use linear equation, or even when to use binary equation. Now, so what we need to do now, we are going to replace the y over dx with equation 2, which we already stated here, and we are going to replace y with what? Vx, which is equation 1. Like I explained earlier, you substitute equation 1 and 2 at the same time. Now let's do that. So we will replace v with what? V plus x dv over dx is equal to x squared plus vs all squared. Don't forget that this is y squared, so all over what? X multiplied by y is vx. Okay, now the next thing you are quickly going to do is to simplify, multiply. Now I understand that, like I explained earlier, it is only dv over dx that you need at the left hand side. Every other thing must be at the right hand side. So I'm going to take this v to the right hand side. Therefore, we are going to have this as dv over dx is equivalent to x squared plus v squared is v squared and x squared is s squared all over x multiplied by vx. We have this as what? Vs squared. Then when we take this v from the left hand side to the right hand side, it becomes minus v. It's always minus v. Okay, now we move to the next page of our board. This will have given us x dv over dx is equal to, now when we look at the numerator here now, you find out that you have s squared at the first term, and at the second term you also have s squared. That means I can factorize out s squared from the numerator. Then we put down s squared, open the brackets. Now s squared divided by s squared will give us 1, and vs squared, v squared, s squared divided by s squared, we are going to be left with what? V squared. We have this as plus v squared all over v x squared minus v. Now s squared takes care of s squared. Don't forget the policy or the rule that this x at the right hand side must completely eliminate each other. Are you there? Now if this is understood, then we have this as x dv over dx is equivalent to 1 plus v squared over v minus v over 1. Now we have eliminated x from the right hand side and leaving only the right hand side to be in terms of v only. All we need to do is to simplify. Now understand that the LCM of v and 1, LCM of the denominator is v. So we have this as x dv over dx is equal to, you put down the new denominator which is v. Now v divided by v is 1, and 1 times the numerator is 1 plus v squared. Also, v divided by 1 is v, and v times minus v, we will have this as minus v squared. Now understand that 1 plus v squared minus v squared, this guy will cancel out this guy. Then we have x dv over dx is equal to 1 over v. This is what we have at the left hand side, and this is what we have at the right hand side. Now we see that this equation is now a function of x and v. And at this point, you can separate v from x. How do we separate v from x? Now we can separate the variables. Separate the variables. Alright? Now, to separate the variables, all we need to do is to find a particular factor such that when we use it to multiply the left hand side and the right hand side, we will be able to separate the two variables. And how do we get that done? Just say, come here and say, multiply both sides by then generate a fraction. Okay, now at the numerator, I know that this v is expected to be at the left hand side, while x and dx is expected to be at the right hand side. So all I need to do is the ones that are the denominator, v is at the denominator, dx is at the denominator, so they will now become my numerator here, v dx. And now s is at the numerator here, then it will become my denominator. I'm going to multiply this whole equation by this to separate the variables. Then we have this as x dv over dx multiplied by v dx over x is equal to 1 over v multiplied by v dx over x. All I need to do now is that this guy takes care of this guy, this guy takes care of this guy, and this other guy takes care of this. So guys, what do we have left here? All we just have here now is v dv is equal to what? 1 over x dx. And now that you have been able to separate v from x or vice versa, all you need to do is to integrate. And before we integrate, we have to introduce our integral. Therefore, we have the integral of v dv is equal to integral of 1 over x dx. Now understand that when you integrate v here is a linear function, or a polynomial function, or a quadratic function, any of the functions, right? When I integrate v, I'm going to increase the power by 1 because v is the same thing as v raised to power 1. So when you integrate, you increase the original power by 1. So if I add 1 to the existing power there, I'm going to have 2. I will have this as v raised to power 2. Now divide everything by the new power. We are done with the left hand side. Then we come to the right hand side. When you integrate 1 over x, we will have this as what? Ln x plus k. It's as simple as this. Now that we have successfully integrated this function or this equation, all we need to do is to replace v, because the question we were given did not come in terms of v and x, but in terms of y and x. So how do I replace v? I will now make use of equation 3. And equation 3 says, now you just say recall that v is equal to what? Y over x. So I will substitute. Now at this point, I'm having this as 1 over 2 into y over x all squared. This is v, 1 over 2. Then is equal to ln x plus k. And now at this point, this will have given us y squared over 2x squared. Now when you square y, you have y squared, and when you square x, you have x squared ln x plus k. I can decide to make this a linear function by cross multiplying. So I can decide to say this is all over y. Now when I cross multiply, we will have this as y squared is equal to 2x squared into in x plus k. You can leave your answer here, you can expand. It's as simple as this. It's as simple. So you can leave your answer here, but let me push it for that. So this will have given us y squared is equal to 2x squared. Alright? 2x squared in x plus 2kx squared. And I'll simply say let 2kx squared be equal to a, because this is a constant and you can replace a constant by another simple or simpler constant. Therefore, finally we have this as y squared is equal to 2x squared in x plus a. This is our answer. Like I said, you can stop here. You can either stop here or stop here. It's a matter of choice. So you see that these equations are very, very easy to solve, but with the help of principles. So don't forget, guys, if you have not subscribed to this YouTube channel, do consider subscribing to this YouTube channel and ensure that you turn on the post notification bell for more exciting videos. We love you. Don't forget to share this video, like this video, and make your necessary comment. Now let's get to question number 3. Okay, now we have question number 3 on the board, guys. And we are asked to solve the y over the x is equal to 2xy plus 3y squared all over x squared plus 2xy. Now let's check if we can factorize the numerator. Now the first term contains x and y, but the last term contains only y squared. I cannot factorize this to separate x from y. And the same happens at the denominator. Here I have x squared, but here I have 2xy. X is common, but y is not common. Alright, so we will not be able to separate these variables here. And in as much as we cannot separate the variables, all we need to do is to move down to what? Homogeneous equation. I am explaining this because of the fact that in examination hall or in any exam that you are writing that involves this differential equation, it will not be stated the method you are to use. No. But you will identify the question and know the method that will be suitable. So that's why you see me emphasizing on how to identify them. Are we there? Okay, now, what do we need to do? At this point, all we simply need to do is, now that we have identified that these functions here cannot be separated directly, all we need to do is to find a way to separate them. And how do we do that? We will only use homogeneous equation, where y is equal to vx and dy over dx is equal to what? V plus x dv over dx. It's as simple as this. So we come here and replace the y over dx with this guy and also replace y with vx. Because I explained earlier that you make use of equation 1 and 2 at the same time. You make use of equation 3 when you have already integrated. Are you there? So now we are using equation 1 and 2 at the same time. Now in place of this guy, we have v plus x dv over dx is equal to, now in place of y, this is 2x, y is vx plus 3, y is vx all squared all over x squared plus 2x and y is vx. So we just replace y with vx. Anywhere we see y, put vx. Now we have done that. Then the next thing we do is that we know that anytime we are dealing with homogeneous equation, the v at the left hand side must be taken to the right hand side, leaving only x dv over dx. Therefore, these are all conditions that you just need to do. The x is equal to, now when I multiply out this will have given us 2v s squared. When I multiply out this will have given us 3v squared s squared all over s squared plus 2vx squared. When you look at both the numerator and the denominator, each of the terms carries s squared. So that means we can cancel out s squared. So what we need to do now is to factorize both the numerator and the denominator. And then minus. Understand that we are going to take this v from the left hand side to the right hand side, then it becomes minus v. Then this gives us x dv over dx is equal to, and the numerator s squared is common. So when I remove x squared from here, we have 2v, while the other one is 3v squared. Then all over, at the denominator, we have s squared. And when we divide s squared by s squared, we have 1. And when we divide this by s squared, we have 2v. We have 1 plus 2v. This is what we have. Now, at this point, the next thing we do is to put down minus v, which is what we have here. Now, the next thing we do here is to cancel out this guy. Then we have dv over dx is equal to 2v minus plus 3v squared all over 1 plus 2v minus v. And now we see that at the right hand side now, we have successfully eliminated x. And we have the right hand side to be a function of v only. Then we need to simplify so that they have common denominator and one simple numerator. Are you there? Now, to have that done, the LCM of this guy and this guy is still 1 plus 2v. So we have this as x dv over dx is equivalent to 1 plus 2v. This is the denominator. Now, 1 plus 2v divided by 1 plus 2v will give us 1, and 1 times the numerator corresponding to this denominator. We will still have this as 2v plus 3v squared. Then minus 1 plus 2v divided by 1 will have given us 1 plus 2v. And 1 plus 2v times this guy, we will have this as v multiplied 1 plus 2v. Okay? Now let's expand. If we expand that, we have this as the v over dx is equivalent to 2v plus 3v squared minus v plus minus 2v squared. V multiplied by 1 and minus v multiplied by this guy all over 1 plus 2v. Now guys, at this point we have the v over dx is equivalent to now v my 2v minus v, this will have given us v, and this guy 3v squared minus 2v squared, this will have given us v squared all over 1 plus 2v. Now we have successfully simplified the right hand side to have only one denominator. The next thing we are quickly going to do is to separate the variables. Now I want to teach you another method I have not taught you before. Another short way to separate the variables under homogeneous equation. Another short way. Now listen carefully. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notifications there for more exciting videos. Love this video, share this video, and make your necessary comment. Don't forget to like the video. Okay, now separate the variables. Now to separate the variables, this is another way, another short method to have this done. All I need to do anytime I am dealing with homogeneous equation and I want to separate the variable, all I need to do, take this denominator here up. Understand that everything here, they are all functions of what? V. Is that correct? So just invert it and have this to be what? 1 plus 2v. And from the left hand side to the right hand side. So from the right hand side to the left hand side now, you invert the fraction. And this will have given us v plus v squared multiplied by dv. Then from the x function, the x will come up, x function will come down. If you look at question number 1, question number 2 that we saw before this question number 3, you will discover that at the right hand side, when we separate the variable, you always have ds over x. It will always be like that anytime you are solving first order differential equation using homogeneous equation. Are you there? Yes. So this is like giving us dx over x. What I mean is it will always be dx over x. Always be dx over x at the right hand side when you have successfully separated v from x. So when you have separated v, denominator here comes to numerator here comes to denominator here. If you understand this, then you can also ignore the methods that we use in question 1 and question 2. Now let's get to work. Now that we have successfully separated v from x, what next? All we need to do is to introduce our integral. And to introduce our integral, we have integral of 1 plus 2v over v plus v squared, or dv. And this is equal to integral of 1 over x dx. Now, I have emphasized over time that anytime you want to integrate fraction, you must pay attention to what you have at the numerator and what you have at the denominator. Now, listen carefully. If we are to integrate 1 plus 2v over v plus v squared, we have a function at the numerator and also a function at the denominator. Of course, we have not solved a problem like this since we started dealing with first order differential equation. But I want to teach you some secrets, which is still the same thing as what we have done before. Now, listen carefully. Now that at the denominator, I have a power of the variable more than 1. Listen carefully now. I have explained that when the power of the variable at the denominator is more than 1, you cannot have name. And that only happens when the numerator is 1. But if the numerator is more than 1, it's not a constant. If the numerator is not a constant, it therefore shows that and you have a variable at the numerator, all you need to do first is to check. if you differentiate the denominator, if it will give you the numerator. That is substitution. Because anytime you have a fraction, you are integrating fraction, you must always check with the method of substitution. And what does substitution does? What you do in substitution is differentiate the denominator and see if it will give you the numerator. That's what you do. Now, in this case now, when we differentiate the denominator, let's see if it will give us the numerator. If it does, we don't need to kill ourselves. Alright, so if I differentiate v, I will have 1 with respect to v. Just the same way if you differentiate x, you have 1. So if you differentiate v, you have v. And if I differentiate v square, I put down the power, then I now have 2 minus 1, and 2 minus 1 is 1. So you discover that when you differentiate the denominator here now, you are going to have the numerator. And anytime you differentiate the denominator, and you have exactly the numerator, your answer just becomes the limit of the denominator. What I mean now is that if I integrate this, having ascertained that if I differentiate the denominator is going to give me exactly the function at the numerator, all I just need to do is to have my answer to be what? The limit of the denominator. That's it. It's as simple as that. So the answer to this question now, as it is limit of the denominator, which is v plus v squared. Alright? But I don't want to do it this way. I want to show it. So if you want to meet up with time, you can do this method if you understand it. But I want to work it out the way it should be, or the proper way, so that for some of us who will become tutors tomorrow, you'll be able to explain this aspect very well, right? So that you know how it is done, not just to bypass it. I just use a shortcut to give you the result, right? So let me work it out so that you get to know how this whole expression will give us the limit of the denominator. Let's work it out. Now, what you do is, once you have ascertained, you have test run. Now, when you differentiate the denominator, you have the numerator. Just say let u, or any other variable. Let me use w. Let w be equal to the denominator that you have there, which is v plus v squared. Alright, are you here? Yeah. Now the next thing we do is to differentiate w with respect to v. And when we do this will give us 1 plus 2v. Now we are going to make the v the subject of formula. Why? Because in this equation, anytime you are using substitution method, you only replace the denominator and the d function. Alright? So for me to be able to replace the v, I need to make the v the subject of formula here. And that's the reason why I differentiated this function with respect to v. So if I make the v the subject of formula, I'm going to have the v is equal to dw all over 1 plus 2v. It's just to take this one up and bring this one down. So I will come to this equation and substitute those values. So I introduce my integral. At the numerator I have 1 plus 2v. At the denominator I have w. Then multiply by, what is the v? We just said now that the v is equal to the w over 1 plus 2v. I can decide to use bracket to enclose these two guys. And this will be equivalent to, at the right hand side we have 1 over x dx. Now understand that this will take care of these guys. Hence, I will have this as integral of 1 over w. The w is equal to integral of 1 over x dx. Now guys, if we integrate 1 over w, we are going to have lim w. So we have lim of w is equal to, when we also integrate 1 over x with respect to x, we have lim x plus k. It's as simple as this. But what is w? W is equal to v plus v squared. So we have this as lim of v plus v squared. We just replace w now. Lim x plus k. Now I can simply say let k be equal to lim a, so that all these functions can be in terms of lim. Let k be equal to lim a, so that I will replace k with lim a. Alright? So in this case, this will have given us lim v plus v squared is equal to lim x plus lim a. And now don't forget that this is lim v plus v squared is equal to lim ax. Like I explained before, that when you have the addition of two different lim, pick one of the lim and multiply their functions. And that's exactly what we have here now. Okay? So that lim takes care of lim, then we have v plus v squared is equal to ax. Now guys, we cannot leave our answer here. We have reduced this to its simplest form. We cannot leave our answer here. Why? Because the question never came with v, but it came with x and y. So how do we replace v? That is where we now make use of what? Equation 3. You simply recall that v is equal to y over x. Now we will come here. We have y over x plus y over x squared is equal to ax. Now this is giving us what? Y over x plus y squared over x squared is equal to ax. Now finally, when we simplify this, LCM of this guy and this guy is going to give us s squared. LCM of x and s squared is s squared. So when I multiply this by s squared, I'm going to have this as what? xy. And when I multiply this by s squared, I'm going to have y squared. And when I multiply this by s squared, I'm going to have ax cubed. This is the answer to this very question. Hope you understand what I just did here. Yes. I want to clear up the fraction. Everything here is in fraction over 1. So how do I clear up the fraction? I need to find the LCM of the denominators. And the LCM of x, s squared and 1 is s squared. So I will now multiply all the whole equation with what? The new LCM. And when I do that, if I multiply this by s squared, 1s cancel 1s, I have this. If I multiply this by s squared cancel s squared, I have y squared. And if I multiply this by s squared, I'm going to have this as ax cubed. So guys, this is the answer to this very question number 3. Don't forget to like this video, share this video to your classmates, and ensure that you subscribe to this YouTube channel and also turn on the post notification bell for more exciting videos. Guys, we will look at the very last question, which happens to be question number 4. To solve x squared plus y squared all multiplied by the y by the x is equal to x multiplied by y, or xy. And now, this is solution. The first thing you must do here is to ascertain the relationship between x and y. Of course, you already have x squared plus y squared here, which shows that you cannot separate x from y directly. Are we there? That is it. But here, the first thing you must do is to ensure that the coefficient of the y over the x is 1. And now it's not 1. So we need to divide both sides by this bracket, which is the coefficient of the y over the x. And when we divide both sides by the coefficient of the y over the x, we will definitely have the y over the x is equivalent to xy over x squared plus y squared. Now that we have this, and we know that we cannot separate x from y, all we need to do is to use homogeneous equation. And how do we use homogeneous equation? We simply recall that y is equal to vx and dy over dx is equivalent to v plus x dv over dx. So now these are equation 1 and equation 2 that we just have, and we are going to substitute equation 1 and 2 into the given equation simultaneously. And how do we have that done? We will replace this by v plus x dv over dx is equivalent to x is here, then v is vx all over x squared plus y squared would have been vs all squared. This is it. The next thing we are going to do now is to multiply out and understand that this v at the left hand side must be taken to the right hand side. Therefore, we have x dv over dx is equivalent to, now when we multiply x by vx, we have this as vx squared all over. At the denominator, this is x squared, while this x all squared would have been what? V squared s squared plus v squared s squared. Now when we take v from the left hand side to the right hand side, it becomes minus v. This is it. Now at the numerator we have s squared, and at the denominator we have s squared. That means you can factorize and cancel out the x function. Don't forget that anytime you are using this method or you have successfully substituted for y, the x at the right hand side must eliminate each other. Now, we have this as x dv over dx is equivalent to v dot x squared all over s squared, open bracket, s squared divided by s squared we have 1, plus v s squared divided by s squared we have v squared, minus. Now guys, we have this to be what? X dv over dx is equivalent to now s squared takes care of s squared. We are leaving the left hand side to be, now we have the right hand side to be in terms of v only, then minus v over 1. Now, at the right hand side, all that we have is v function, and we must ensure that these v functions have common denominator. And to have that done, we find the LCM of the denominators, and the LCM remains as 1 plus v squared. So we have this as dv over dx is equal to, the new denominator is 1 plus v squared. Now 1 plus v squared divided by 1 plus v squared will give us 1, and 1 multiplied by v will give us v, minus this guy multiplied by this guy would have given us v into 1 plus v squared. It's as simple as this. So when we multiply out, let's see what we have. This would have given us x dv over dx is equivalent to v. Now minus v multiplied by 1 is minus v, and minus v multiplied by v squared, we are going to have minus v cubed all over 1 plus v squared. Now v minus v would have given us 0. Then we have x dv over dx is equal to minus v cubed over 1 plus v squared. Now we are almost there. All we just need to do at this point is to separate the variables, because we see now that at the left hand side we have x v function, and at the right hand side we have only v. We can now separate x from v. And how do we do that? We are still going to use the method we use in separating v from x in question number 3. And how does that method work? Now listen carefully. Separate the variables. How do you separate the variables here? Listen carefully. It works for this, any problem at all. Listen carefully. You see now, this v square and this other ones, they are function of v, and we are moving everything to the right hand side. So to move everything here to the right hand side, all you just need to do, swap their position. Numerator becomes denominator, and denominator becomes numerator. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos. Now listen carefully. So this one will now come up 1 plus v squared. Then the denominator will come down. This is v cubed. We have the minus here. Then all the v, all multiplied by the v. Then I want to move x and the x to this side, and I mentioned that you always have the x over x when you are dealing with homogeneous equations. At the right hand side, once you successfully separate v from x, at the right hand side you always have dv over dx, not the x. Okay, so what else is left here? I can decide to multiply both sides by minus so that this minus comes to this other end. So I can decide to leave it here. All I need to do now is to introduce my integral, and this will be of 1 plus v squared over v cubed all dv is equal to minus integral of dx over x. I just multiply both sides by minus. I need the minus to be at the right hand side. Alright? So now listen carefully. The next thing we do is to check this question properly. What do I mean by checking this question properly? We need to ascertain whether this function that we have here is a fraction. Of course, we already know that this is a fraction. And to integrate fraction, we integrate fraction either by substitution method or by sharing the denominator. Now listen carefully. If I differentiate the denominator, there is no way I can have the numerator. Why? Because the numerator contains 2 terms, and the denominator contains only 1 term. So there is no way I can differentiate 1 term to give me 2 terms. So in this case now, there is no way substitution method can work. And also I remember that in one of our classes, or one of the lessons that we had, I explained that anytime you have multiple functions at the numerator or multiple terms at the numerator and you have only 1 term at the denominator, all you simply do is to share the denominator for the numbers of numerators that you have. So now I have two terms at the numerator to one denominator. And that is a simple term. All I need to do is to share the denominator for the two numbers of numerator that I have. So here, so now we have 1 over v cubed plus v squared over v cubed all multiplied by dv is equal to minus integral of 1 over x dx. So guys, at this point, the next thing we quickly do here is to reduce this function. And this would have given us integral of 1 over v cubed plus 1 over v squared over 1 over v or dv. Don't forget that v squared over v cubed will take care of each other. So we now have 1 at the numerator and have v at the denominator, which is equal to minus integral of 1 over x dx. Now at this point we want to integrate this. Now you need to pay attention to when you are integrating a function like this. So if I'm integrating a function like this, you can take note of this anywhere. When to integrate a function like this, integral of this with respect to x, all you need to do is to first of all multiply the outcome by minus 1. So when I multiply this outcome by minus 1, I have minus 1. Then the numerator is 1. Then I will have to reduce this power by 1. I have x raised to the power n minus 1. Then now multiply the coefficient by what? N minus 1. So this is what you do. First is to multiply by minus 1. Next, put down the numerator which is 1. All over, reduce the power by 1. Now multiply the coefficient of that denominator by the new power. That's exactly what we have here. Now let's work it out with this. So to have this done, and the first thing we do is to multiply this function by minus 1. And we are going to have minus 1 all over. Reduce 3 by 1. We have 3 raised to power v raised to power 2. Then multiply the denominator by the power. That's all. Then plus, when we integrate 1 over v, we have ln v is equal to minus ln x plus k. If we integrate 1 over x, we equally have ln x. Okay? Now the next thing we are quickly going to do is to replace v with its value. Of course, we know that the value that we have here is in terms of v and x. That's the equation here. It's in terms of v and x. And now we do not want our answer to be in terms of v and x, because the question came with what? X and y. So how do we replace v? We will recall equation 3. And what is equation 3? It said that recall that v is equal to y over x. So in place of v, we are going to put in y over x. So this will give us 1 over. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for exciting videos. Now also don't forget to like this video, share this video, and make your necessary comment. We love you guys. See you in the next class.